Today we will introduce this UHV-408 high-voltage circuit breaker analyzer. Use it to test the dynamic characteristics of this 4 kV high-voltage circuit breaker. For wiring, first, the instrument is reliably grounded. This is a 4-core wire. It is also yellow, green, red, ABC 3-phase, with a common end. Connect to the measurement port. This is the measurement port, connect it well. Then A1, A2, A3. This is based on the 12-way circuit breaker. Generally only 3 ways are used. Use A1, B1, C1, or A2, or A3, or A4. These ports are all okay. Now we are using A1, B1, C1 port. The other end is connected to the circuit breaker. This is ABC 3-phase. The yellow, green, red, ABC 3-phase is connected to the moving contact. In addition, the black one is its common end. Connect to its other end. Short circuit the 3 phases. Connect them to the same line. These 3 phases can be swapped with these 3 phases. All can be connected. The test line is connected. The next thing to connect is its opening and closing control coil. That is, its internal trigger control coil. Use our instrument to trigger it. This is an external trigger. It is generally not used. It will be connected with internal trigger. This is a 3-core wire. After connecting, the other end is connected to the terminal block of the circuit breaker's opening and closing control. This is our opening and closing control terminal. The closing has a red terminal. The green terminal is connected to it. The black one is the common terminal. Connect them respectively. This is a pure terminal. That is, 2-core wire. 1 red, 1 black. This wire is connected to the control terminal on the test instrument. These are 2 energy storage terminals. This is the energy storage control switch. Then connect it to the terminal. After connecting, you can see that there is now a multi-core wire. It is mainly connected to the sensor. Then the sensor connects the socket. The other end is connected to the circuit breaker. This is a magnetic suction seat. This side can be loose. After loosening, place it in this position. Then twist it to the side. After unscrewing this side, it is a magnet. It attracts it. Align it to the sensor. Just tighten it. It should be noted that the sensor is a magnet. Directly magnetically attract to this hole of the circuit breaker. After attracting it, tighten it. Now you can put it in. The sensor is installed in this way. What you need to pay attention to about the sensor is how to install it. For the installation of the sensor is first inserted into it with this shaft. Tighten the screw. An axis is placed on one end of it here. Tighten the screw. An axis here. There is a screw hole in this place. Align, tighten it. The instrument is connected to a 220 volts power supply. Turn on the power. After turning on the power, here is the parameter setting. This is the characteristic test. Test interface. Here is the data. Data query management. Rec losing test. Underground test. Aging test. The conventional one is to use its characteristic test. Here is the parameter setting. Click OK. Enter the page. This is the sensor position. It is usually connected to the A1 position. Select. This is the type of switch. You can see vacuum circuit breakers, low oil circuit breakers, and sulfur hexafluoride. And its contactor. This is its model. The vacuum circuit breaker is measured. This is its sensor type. There are linear and rotary sensors. Now the rotary sensor is used. This is the length of the sensor. This is its triggering method. There are internal triggering, external triggering, and self-triggering. Self-triggering is manual triggering. External triggering uses an external power supply. Generally, internal triggering is used because the wiring is controlled by power supply. This is its strobe. The set voltage is based on the high voltage switch of the sensor. The high voltage switch is now powered by 220 volts. So it is 220 volts. This is the acquisition time, set to 1 second. This is the storage time, set to 8 seconds. The acquisition time is generally 1 second, and can be set to 1 to 10 seconds. The storage time is generally around 8 seconds, and can be set within 5 to 20 seconds. This is the time for opening and closing, that is, the time without current. Generally set to around 280 milliseconds. Now it has been set. Here is its stroke and time. This is closing. This is the total average speed. This is its closing, before closing and after opening. Now it is opening, before opening and after opening. This is basically set here. Then this is default, save, and exit. Save, set here. Set the number, and test personnel. Exit. After setting, enter the test interface. Click test. This is closing. Opening. Storing energy. Save. Zoom in and out. Print and exit. Now because it is opening, it is just stored energy. You can do its closing test. Click on closing. You can see the data comes out. This is closing. Its time. The second line here is its bounce time. The third line is its number of times. This is its synchronization. Here are its travel, opening distance, and over travel. This is also its stroke. This is the average speed. The speed just closed. Its test voltage, current, coil resistance, this place is the tester. Here ABC, they are the closing state. Just tested as the closing. Now all the others are in the opening state. Now we are in the closing state. You can test its opening. Click directly, the opening data comes out. The whole experiment is completed. If you need to save, you can directly click the Save or Print button. Its data comes out. You can see the test results come out. Then return. This is data management. The measured data is here. This is the rec losing experiment. After entering the rec losing test, there are several types of tests, such as closing and opening, opening and closing, opening and closing, and opening and closing. This is energy storage. There is also saving. Zoom in and out. Print and exit. This test is the same. First, set its parameters. After setting it up, perform its rec losing test. That is, close and open and close, and then open and close. It is exactly the same as the steps of the test just now. Now it is in an open state. You can measure close and open. For the open, we close first and then open. Because it involves closing. First, store energy. Turn on the energy storage switch. The instrument has stored energy. Turn off the energy storage power supply. Then perform the closing and opening experiment and click. The data of its two trajectories will come out. The instrument is very simple and very intelligent. Exit now. The next step is the low jump test, which is its minimum operating voltage. For the low jump test, set its initial voltage. Then accumulate the voltage, and it will accumulate a few volts each time. For example, if I set 1 volt, it will increase by 1 volt each time. This is the current voltage. This is the lowest nuclear magnetic voltage and its lowest bifurcation voltage. The low jump test can be automatically low jump. It will automatically perform low jump test. This is stop, this is reset. You can manually perform closing low jump and opening low jump. You can print and exit. It is currently in the opening state. If we want to do low jump, it needs energy storage. If it is in the closing state, it does not need energy storage. First, fill the energy of the circuit breaker. Turn on the energy storage switch. The voltage of the low jump just now is 66 volts. You need to change the voltage to 220 volts before you can store energy. After storing energy, perform low jump. Now just set it to 66 volts normally. The last one is the aging test. This project is only for the life test of the circuit breaker. It is a special function. Under normal circumstances, the configuration can only perform hundreds of aging tests. If you need to do more times, you need to inform before ordering. This is its save, start, pause, clear key, exit key. The instrument introduction is over. Then if you want to control the opening and closing of the circuit breaker on site. If its switch does not work, the wiring of the opening and closing of the circuit breaker on site is incorrect. To handle it, you need to find our wiring diagram on site. Ask our professionals. Find out its closing and opening coils and switch nodes. Be sure to connect the terminals of the circuit breaker. Otherwise, the control coil in the circuit breaker may burn out. Also pay attention to what type of circuit breaker it is, how big its control power supply is, for example, 110 volts or 220 volts.